In this last module, Module 7, we want to pull every concept from the previous 6 modules into a single coherent picture. We'll trace real attack paths through the systems and controls you've learned about, build a practical defensive checklist you can apply in your environment, and point you toward the standards and frameworks that formalize these practices across the industry. By the end of this module, the goal isn't just that you understand the individual concepts, it's that you can see how they connect, how a weakness in one area creates risk across multiple others, and how controls in different areas reinforce each other. Let's look at what each module contributed to the overall security picture. Module 1, we talked about the fundamental premise. The connectivity creates attack surface. So every network connection, every remote access path, every protocol port is an entry point into the system. The more connected an OT environment becomes, the more entry points exist. In Module 2, we discussed IP addresses and that they are device identities on a network. A subnet is a neighborhood. An unknown IP address on your network is an unknown person in a secure facility, which is worth finding and identifying. In Module 3, we covered protocols and ports, what they are, what ports OT protocols use, and why open ports on OT devices are an attack surface. Critically, we talked about why plaintext protocols like Telnet and FTP are dangerous in any connected environment, and why the industrial protocols themselves like Modbus, DNP3, Ethernet over IP provide no authentication or encryption by design. In Module 4, we covered the architecture of an OT network. We used VLANs to create zones. We talked about the Purdue model to provide a common vocabulary for those zones, and DMZs to buffer OT from IT. We also discussed data diodes for environments requiring absolute one-way enforcement, and segmentation failures that undermine the architecture in practice. In Module 5, we discussed firewalls, the different types, how the rules work, the default deny idea, common misconfigurations, and secure remote access. Firewalls enforce least connectivity at zone boundaries. In Module 6, we covered assessment, or how to see what's actually on the network and decide what's normal and what deviates from normal. Visibility is the prerequisite for everything else. So these aren't independent topics, they all relate to one another, and each one reinforces the others. So defense in depth is the security principle that ties all of these layers together. No single control prevents all attacks. A firewall with perfect rules can be bypassed by a bridging device. A perfectly segmented network can be undermined by a forgotten vendor remote access path. A completely passive network monitoring platform can't protect what it doesn't see, so no single layer is complete. The goal of defense in depth is to ensure that when one control fails, another is in place. So an attacker who bypasses the perimeter firewall will hit a VLAN boundary, or an attacker who crosses the VLAN boundary hits a more tightly configured inner firewall. An attacker who exploits a vulnerability in one device finds they have no credentials for the next system. Each layer buys time, limits the blast radius, and creates opportunities for detection and response. This is the same philosophy as a process safety system. You don't rely on a single safety instrumented function to protect a hazardous process. You have multiple independent layers: basic process control, operator alarms, safety instrumented system, physical relief devices. Each layer is independent and each has its own failure mode, and the combination provides protection that any single layer couldn't. So defense in depth in network security works the same way. We have multiple layers, each of them are independent, each are catching what the others miss. Security requires 3 things working together, and the absence of any one of them leaves the others insufficient. First of all, the technology. You have to have the firewalls, VLANs, encrypted protocols, access controls, passive monitoring platforms, multi-factor authentication. So technology implements the controls. The next piece you need is the process. So you need documented procedures for approving network access requests. You need to be able to manage vendor connections, reviewing firewall rules, investigating security alerts, responding to incidents, maintaining asset inventories, and controlling network changes. So process ensures the technology is configured correctly and maintained over time. Technology without process is misconfigured technology. The third piece you need is culture. meaning every engineer, technician, and operator who works in or around the OT environment understands their role in maintaining security. They know how to report anomalies. They treat unexpected devices and unusual access requests with appropriate skepticism, and they see security as part of the job rather than somebody else's problem. Culture is what keeps process from being ignored. Technology without process is a firewall with no review, a monitoring system with no one looking at the alerts, and default allow rules left in place because nobody was responsible for reviewing them. Process without culture is a documented procedure that nobody follows because security isn't seen as relevant to their work. So all three together create a defensible environment that improves over time. In the next two videos, we'll trace 4 specific attack paths from initial compromise to OT impact, and we'll map each step to the concepts and controls from this course. Seeing how real attack patterns interact with the controls you've learned makes the connection between theory and practice concrete.